Hi guys, so in this video we will solve this problem, solve 7n by 8. Okay, so let's understand what the problem says. Problem says that we will be given an integer n and we have to find the value of 7n divided by 8. Okay, and we cannot use any division or multiplication operator. Then we have to find this value. So this was for the problem part. So now let's see how we can solve this particular problem. So we will be given n and we are required to find 7n divided 7n divided by 8, 7n divided by 8. Okay, and we have to not use multiplication and division operator. So how can we solve this without using multiplication and division operator? So one way of writing this problem is what 7n can be written as what 8n minus n divided by 8. Okay, now we can solve this problem, but you might be thinking, even if we write 7n as what 8n minus n, still I need to perform what a multiplication operator, that is 8 times of n, and still I need a division operator, that is 8n minus, after performing 8n minus n I need to divide it by 8. So for that I still need a division operator. So how will we able to eliminate this use of this multiplication and division operator? So how we can eliminate is that there is a technique like in bit manipulation. There is a way through which what we can generate the multiplication of power of 2 and division of multiplication of power of 2. What do I mean by it? If I want something like this, 2 raised to power n times any value x, then I can generate this using what bit manipulation. There is a way in bit manipulation. Okay, and also if I want something like this, any number x divided by 2 raised to power n, this also can be generated using bit manipulation. Okay, so what we will be doing is that we will be using bit manipulation technique to generate what 8n can be written as what 2 raised to power 3 into n. So this can be generated using bit manipulation. Okay, then this whole number 8n minus n, let's suppose this is equal to y. Okay, now we want what y divided by 8. So this is also what 2 raised to power something, that is y divided by 2 raised to power 3. So this can also be generated using bit manipulation. So here also we will use bit manipulation. So we will avoid the use of what multiplication and division operator, and we will use bit manipulation to solve this answer. Okay, so this is what we are going to use to avoid multiplication and division. So now let's move on to how, means what technique we are going to use to generate this. Okay, so let's move on to that part for now. So what technique we are going to use is that, suppose we have any number n. Okay, let's suppose we have any number n. Okay, and if we left shift that number by x times, then it is equal to what, n into 2 raised to power x. So this is one of the property. And one more property which we are going to use is that, suppose we have a number n and we are right shifting that number by x, so it is equal to what, n divided by 2 raised to power x. Okay, so these are the two properties which we are going to use. So if we use this particular property, we will be able to generate our answer. First, let's do one thing. First, let's suppose, for now what we will do, we'll let's suppose that these actually also these properties are true, but for now let's not move on to the proof part for it. What we will do, we will assume that yeah, we know that this property is true. Then how we are going to generate our answer? First, let's generate our answer. After that we will see like how it is working, how it is equal to n left shift x is equal to n times of 2 raised to power x, and n right shift x is equal to n divided by 2 raised to power x. How these two are similar, we'll also see that. Okay, for now let's see that if we know that these properties work, then how are we going to deduce our answer? Okay, so we want what, we will be given a number n and we want 8 times of n minus n divided by n. Okay, means 7n by 8 can be written as 8 times of n minus n divided by 8. Okay, so we want what, 8 times of n, and this property can help us. If we left shift property, if we want n times of 2 raised to power x, what we can write, we can write n left shift of x. So here what we want, 8 times of n, and 8 times of n is what, 8 is what, 2 raised to power 3, 2 raised to power 3 times of n. So if we look at this property, what do we need to do? N left shift of x is equal to n into 2 raised to power x. So this 8n can be something, 8n can be written as what, 8n can be written as n left shift of 3, then we will get 8n minus n. If we perform, then we will get what, 8n minus n. So let's suppose, let's make a number y. or let's suppose this is the numerator part. So let's make a variable numerator. Numerator will be equals to what? N left shift of 3 minus of n. So we got the numerator. Now what we want to divide it by 8, and if we want to divide any number by 2 raised to something, what we do right shift by x. So 8 can be written as again what? 2 raised to power 3. So x is 8. So what we can write? Our answer will be what? Numerator right shift of 3. Yeah, so using this we will be able to generate our answer. So this was for the answer part. So this is what we are going to do for our answer. But for now, what we will do, let's understand these things, like how it is working, how it is equivalent to that. So what I am saying, according to this formula, yeah, we know this part. So now let's I think we are done with this, so we'll move on to the coding part a little later. Before moving to coding part, let's understand these parts. Okay, so here what we have written, n left shift of x is equal to n into 2 raised to power x. So if we write something like this, 1 left shift of 1, then it will be equal to what? 1 into 2 raised to power 1, that is 2. If we write something like this, 1 left shift of 2, it will be equal to what? 1 into 2 raised to power 2, that is equal to 4. If we write something like this, 1 left shift of 3, it will be equal to what? 1 into 2 raised to power 3, that is 8. If we write 2 left shift of 2, it will be what? 2 into 2 raised to power 2, that is equal to what? 4 2s are 8. Okay, so this will go on, it works in this particular pattern. But let's see how, means why it is equal to multiplication of 2. Okay, let's see that part also. But before that, give me a second. Let me minimize this one and keep it with us. Okay, so we know this formula. I'm keeping it over here. Okay, yeah. So now let's suppose any binary representation of a number. Let's suppose we have a number 1101 something like this. Okay, so if we write it binary, so if we means, if in binary it is what? If you want to convert it in decimal, it is 2 raised to power 0, it is 2 raised to power 1, it is 2 raised to power 2, it is 2 raised to power 3. So if we write this number in decimal, it will be what? 2 raised to power 3 into 1 plus 2 raised to power 2 into 1 plus 2 raised to power 1 into 0 plus 1 into 2 raised to power 0 into 1. We can write this number as n. So let's suppose this is n. Okay, so this will be equal to what? N. Okay, now let's suppose what we will perform. We will perform n left shift of 1. So how it is equal to n left shift 1 is what? N left shift 1 is n into 2 raised to power 1, that is 2 into n. Let's see how it is equal to 2 raised to n. So if we perform left shift n, this number will be equal to what? This number will be 1101, and an extra 0 will be added. Okay, and from here this 0 will be removed. This is what? 32-bit number. So after these 4 bits, all these bits over here are what? 0 0. So I have not written those bits. Okay, simply this bit will be discarded from here. Yeah, let me make that also. So here it will be total 32 bits, all the remaining bits are what? 0. So when we will perform a left shift, so this last bit will be discarded from here and a new 0 bit will be added from the back. Okay, so this part is happening in the backend, but I have not written those 32 zeros over here. For understanding, you can understand like this is actually happening. Okay, so this was happening over here. So this bit got discarded and a new bit got added from the back. Okay, so now if we see what are the if we want to convert it in binary, it will be what? 2 raised to power 0, 2 raised to power 1, 2 raised to 2, 2 raised to 3, 2 raised to power 4. So if we write this number, this is equivalent to what? 2 raised to power 4 into 1, 2 raised to power 3 into 1, 2 raised to power 2 into 0, 2 raised to power 1 into 1 plus 2 raised to power 0 into 0. Okay, so if we take a 0 common over, if we take a 2 common, let's take a 2 common over here. So if we take a 2 common in all of these terms, what we will get? We will get 2 raised to power 3 into 1 plus 2 raised to power 2 into 1 plus 2 raised to power 1 into 0 plus 2 into 1 plus 2 raised to power 0 into 0 whole divided by 2. But this term is what? Multiplied with 0. So even if we do anything, 0 multiplied by anything is what? 0 only. So we can simply ignore this term. So it is what? 2 raised to power 3 into 1 plus 2 raised to power 2 into 1 2 raised to power 1 into 0 plus 2 into 1. So if we look clearly, this term and this is what exactly same. So if this is n, so this is also what n. So this can be written as what, 2 raised to power 1 into n. So if we perform left shift by one time, it is equal to what, 2 raised to power 1 divided by n, and that is what we have written over here also. So this is why it is actually working. Let's take one more example. What will happen if we will left shift by 2? Okay, so if we perform left shift by 2, what will happen is that, and left shift of 2, it is equal to what, n into 2 raised to power 2, it is equal to 2. And let's see why it is happening. So our number was what, 1101 was our number. So 1101 was our number. So if we perform a left shift by 2 operations, what will happen? Two new zeros will be added, so it will get 110100, and this is a 32-bit number, so two zeros from this place will be discarded also, but I am not writing the zeros over here. Okay, so this number will get converted to something like this. Okay, so this will be 2 raised to power 2 into n. So if we write binary, this is what, 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3. So if we write 2 raised to power 3 into 1 plus 2 raised to power 2 into 1 plus 2 raised to power 1 into 0 plus 2 raised to power 0 into 1. So this is what, n. Okay, so now if after performing two left shift operations, this is 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5. So it will be what, 2 raised to power 5 into 1 plus 2 raised to power 4 into 1 plus 2 raised to power 3 into 0, 2 raised to power 1 into 1 plus 2 raised to power 1 into 0, 2 raised to power 1 into 0 plus 2 raised to power 0 into 0. If we take a 2 raised to power 2 common, so what we will get? We will get 2 raised to power 3 into 1 plus 2 raised to power 2 into 1 plus 2 raised to power 1 into 0 plus 2 raised to power 3 by 2 is what, 1, and this will be 2 raised to power 5 4 3 5 4 3 2. Here it will be 2. Okay, mistake. So if we take a 2 raised to power 2 common, it will be 2 raised to power 0 into 1 plus, here it is what, multiplied with 0, multiplied with 0. So if we multiply by 0, what we will get? We'll get 0 only. So these are simply 0. So we can simply ignore these two zeros. So what we will get, 2 raised to power 2 into 2 raised to power 3 into 1, 2 raised to power 2 into 1, 2 raised to power 1 into 0 plus 2 raised to power 0 into 1. Now if we look clearly, this is n and this is also what, n. So this can be written as what, 2 raised to power 2 into n. Okay, so this is, we can see over here, if you perform left shift by 2, it is equals to what, 2 raised to power 2 multiplied by n. So that is why this particular formula is working, like which we have written over here. That is, if we perform left shift by x on any number, it will be equals to what, n into 2 raised to power x. Okay, so this was for left shift part. Now let's see that it's the same for right shift also. Why similarly right shift is equal to that. Okay, we can mean right shift is also working in the same way, but let's take a small example for that also. So similarly, yeah, so similarly, let's suppose the number is 1101, so this can be written as 2 raised to power 2 raised to power 3 into 1 plus 2 raised to power 2 into 1, 2 raised to power 1 into 0 plus 2 raised to power 0 into 1. Okay, now if you perform a right shift on this, that is n, this, if this is n, if we perform right shift of this will be equal to what, n divided by 2 raised to power 1, it is equal to that. Let's see why. So if we perform right shift, what we will get, 1101. So this particular bit will be discarded and a new 0 bit will be added from the back. So what we will get, we will get something like this. We will get 0 1 1 0. So if we write the binary of this, means if we write, so what we will get, 2 raised to power 3 into 0 plus 2 raised to power 2 into 1 plus 2 raised to power 1 into 0 plus 2 raised to power 0 into 1. We will get this. Okay, let's suppose this is n dash, this is the new number. Okay, and this was what, our original number n. So now if we see clearly in this original number, let's let's divide this original number by 2. So what we will get if we divide by 2, what we are getting, 2 raised to power 2 into 1 plus 2 raised to power 1 into 1 plus 2 into 0, that is plus 2 raised to power 0 divided by 2 into 2 raised to power 3 to 1 0, yeah, 3 to 1 0. So 2 raised to power 0 divided by 2 into 1, so it will be 2 raised to power 2 into 1 plus 2 raised to power 1 into 1 plus 2 raised to power 0 into 0 plus 2 raised to power 0 by 2 will be what, 2 raised to power minus 1. So we can simply write it as 1 by 2, and 1 by 2 will be what, 0 point something. We will again, means this is 0 point something, so decimal will be what, so we can simply write it 0. So it will be what, 2 raised to power 2 into 1 plus 2 raised to power 1 into 1 plus 2 raised to power 0 into 0. Okay, now if you look at this particular term, here it is what, 2 raised to power 3 into 0, so 0 multiplied by something will be 0 only. So 2 raised to power 2 into 1 plus 2 raised to power 1 into 0 plus 2 raised to power 0 divided by 1. So this is what, n dash, and this can also be written as what, n dash. So what we are seeing, n divided by 2 equals to n dash. So if we are performing a right shift operation on n, so it is equal to on n. So what is it equal to, that is, if n right shift of 1 is equals to what, we are getting n dash, and n dash is what, n right shift of 1 equals to n dash. Let me write it clearly, n right shift of 1 equals to n dash, and n dash is what, n by 2. So we can see over here that performing right shift operation, why is it equal to n by 2. Similarly, when we will perform right shift by 2, we will be able to see that n right shift by 2 will be equals to n divided by 2 square, and so on. So okay, so why this formula is working, I guess this has been clear. So, and how we are going to solve using this formula our problem that we have already discussed earlier. So now let's move on to the coding part. Let's have a look also that what we are going to do, since we want 8 raised 7n by 8 can be written as 8n minus n by 8. So multiplying 8n we can generate by what, left shift by 3 minus n. So this is our numerator. Then after that we want to divide by 8, so what we'll do, we'll take a right shift by 3. Okay, so let's now try to code it. So we'll be given a number n. So okay, so let's first make numerator. Our numerator was what, n left shift of 3 minus n. Okay, now our answer will be what, numerator right shift of 3. Finally what we will do, print our answer. Okay, let's try to run this code. It is giving correct answer. Let's try to submit it. It is getting accepted. So yeah, this was for this particular problem.